Thank you. So thanks everyone for coming out. I'm Mike. I've been doing security consulting for 10 years. I studied math and physics, and my focus is on web app security and code review. So currently we're in the period of evolution of the internet. So it started off pretty simple with servers scattered around, it became the internet, became the cloud, and now we're going into this Internet of Things thing, and it's kind of hard to see where exactly we're headed, how is security going to be affected, what exactly is going to happen, right? So during this evolution, the market pressures that have influenced the devices that are connected to the internet, mostly it's because devices are cheap and easy to use. So these are the two forces pushing this evolution. And that's really disfavoring security. So both from a hardware design perspective and from a security perspective, security is not being emphasized as much as it should be, and it often gets forgotten and left behind. So what's happening is, as all these IoT devices are going to come online, there's going to be quite an increased attack surface because all these devices are going to be insecure, they're going to be scattered everywhere, and it's going to be pretty easy to find some kind of vulnerable device somewhere. And on top of that, a lot of these devices are going to have additional metadata like location information, knowing what's in proximity to those devices, knowing who their owners are, things like that. So the chance of actually being able to conduct a targeted attack against a specific person or a specific location or a specific device, that's going to increase as well. And so what's happening is it's going to be really difficult to protect all these devices. And over the next 40 minutes or so, I'm going to talk about the 3 key challenges that I see in securing the Internet of Things, along with a few steps that we can take towards making it a secure environment. And hopefully by the end, we'll see kind of what's the promise, what will the Internet of Things look like maybe in 5, 10, 15 years, where we can actually rely on it in a secure manner and just have it facilitate our lives. So the beginning was just BBSs, which was just people having computers in their house scattered wherever they lived, and with a modem and a phone line connected to it, and then you'd have to dial in. And it really mattered where you were and where these servers or these BBSs, bulletin board systems, were, because you didn't want to be spending, long distance charges on your phone just to connect to a BBS to download some porn or something. So that was really, it was a difficult and really loosely connected environment. When it evolved into the internet, because computers got beefier, internet connections got better, it was much easier to connect to distant locations. That's the kind of the middle picture there. So there was more interconnectivity happening between all the servers, more like what we're kind of used to now. And so what's happening now is we're evolving into the cloud. And what the cloud is doing is it's virtualizing all of these physical systems, putting them in the cloud, facilitating the interconnections between all the services, facilitating connections between different clouds. And wherever you are in the world, you can pretty much rely on being able to connect to whatever service you want, just because the cloud it's not tied to any specific location, and neither should you be in accessing it. So the cloud is here. And who actually uses the cloud nowadays? Well, mostly we see by an IDG study, 45%, the average company has 45% of their IT in the cloud now, meaning they've managed to offload a lot of their existing processes into cloud services using online, just spinning up a VM whenever they need. And by the end of the year, that should go up to 59%. So why do people use the cloud? What are the main drivers for adoption of the cloud? And that's because it's easy to use. So it was a bit difficult at the beginning, but of course, as the clouds have evolved, a lot of them have similar feature sets. So now they compete on value-added services like how easy is it to use, how easy is it to add on extra things. So it's quite easy to use. It's cheap. So compared to actually owning your own data center, compared to owning your own actual physical hardware that's only used maybe 10% of the time, you can just pay for that percent of the time and some extra fee to use the cloud, and it makes your eventual budget much lower. And it's scalable, so you can very easily spin up a new VM to add extra processing power to whatever you're doing if you need it. So you might not need the extra power, but it's actually quite easy to get done. But then the main reasons against using the cloud are vendor lock-in. So if you're using Microsoft's cloud, maybe you can't really interface with all your Oracle stuff or whatever other service provider you're using. There's not as much interconnectivity, but that's beginning to change as well. There's issues with security and compliance. So if you have all of your data in the cloud, can you be sure that it's secure? And at the beginning, it was kind of ridiculous to hear people say, well, we're leveraging cloud services to manage our customer portfolio. Really what they were saying is we put all of our customer data into the internet somewhere. And that was kind of a scary thing, but of course the security of the cloud is getting better because all these cloud providers are competing on this as well. And so that's getting a bit locked down more. And then there's, of course, a lot of knowledge issues. You need to have people who are technically capable of understanding, first of all, your internal processes and how they can be mapped into the cloud, as well as the hardware that you're using and how that's going to need to change, how all these systems are going to need to connect differently to be able to actually make use of all the features in the cloud. And now actually these why and why nots map pretty well to the Internet of Things. So the current main adopters of Internet of Things technology are retail organizations, manufacturing, and transportation. So these three use cases, they're going to push standardization of some IoT components. Ideally, this is going to just mass produce all these components and then drive the costs down. So currently, a lot of IoT devices are plug and play, easy to use, so that's the first point. They're also pretty cheap. You're getting a flood of them from all kinds of suppliers from all over the world, and they don't really focus on security that much. They're scalable as well. So if you need an extra IP camera or if you need additional storage at home, you just buy another network-attached storage thing and you just plug it in and you're good to go. And why not? Again, it's vendor lock-in. So if you have the Apple iWatch or something, you're now tied into Apple's ecosystem, and it might be hard to have your Apple phone or watch work with your Android device and work with whatever other stuff you've got, because of course, every vendor wants to own the entire ecosystem, so they don't really want to share too much. There's, of course, security issues, like with the IP cameras, that can be basically assumed insecure by design. So as soon as you plug it in, you're probably already somebody's watching you. And there's, of course, knowledge issues as well, because managing your own IoT network, for example, if you're at home, you might not really understand what data is being passed around by all these IoT devices, how to properly manage them, how to secure them, how exactly you can use them in a way. We're just at the turning point now, so there's really very little knowledge about how IoT is going to apply and impact our lives. So either way, IoT is coming. And we're in the middle of that transition now. So there's going to be exponentially more devices that are going to be connected to the internet, and they're going to be sending a lot more data all around the place. Sensors all over the world are going to be giving the internet a digital nervous system, and global access to location-aware and proximity-aware devices is going to make protecting your identity and the identity of your devices and the data actually flowing between all these devices, it's going to be much more important to protect all of that. So what is the promise? Why do we want the Internet of Things? Well, the idea is that it's going to make our lives easier and more comfortable in general. So our data is going to follow us everywhere, and that might be data like your favorite music, your favorite color, your favorite food, simple things that you might use to just affect the environment wherever you go. If you walk into a store and the lighting changes to something you like and your favorite song comes on, or you walk in through the door and you've got a theme song that triggers every time you go to the store or something, that might make you more at ease wherever you go, and of course, more willing to spend your money. And then additionally, you'll be able to access anything anywhere. So data like coupons at a store. Maybe every day you pass by a store on your commute, and one of those stores is going to be selling something that, because of all the data analysis, it knows you want this device. So something they're selling, and they're going to offer you a one-off coupon just for you to go purchase this. And it's going to make life a lot easier for you because you want something. They want to sell it to you. You're going to be there anyway, so you might as well know that there's a sale going on. Additionally, there will be data at home that you might want to access, like what's in your fridge. Or maybe you'll be at home and you want to access what's in the fridge at work, to see what's there. Do you need to bring extra snacks in or something? And the biggest driver is going to be, of course, marketing and easier purchasing. The idea being that if you can predict what people want to buy, if you can walk into a store and they know what you want already, it's going to make it much easier for them to sell you stuff. And if you can just basically pick stuff up and walk out of the store and it charges you automatically, that's going to be much easier from a consumer's perspective as well. But ultimately, all this comes down to data, the data that's being shared by you and about you among all these other companies. And so it's going to be really important to make sure that that data is secure. But before you can actually share data with anything, you need to know who you're sharing it with. So you need to have some sort of way to identify devices. With millions and billions of connected devices, there's going to be a real need to be able to uniquely and securely identify each device. So identity management, first of all, is going to boil down to mutual authentication. There's going to need to be a way for devices to be able to communicate securely with each other, know who they're communicating with, and both sides need to be able to authenticate each other to know that they're speaking with who they expect to be speaking with. So there's already technology for this. Public key infrastructure, you can get certs by GlobalSign, Komodo, Amazon, etc. That's pretty easy to do. There's already like quite big scale, especially Global Sign. I think they have the largest thing. They can just generate billions of certs for you. So it's done. It's trusted and it's pretty secure as far as we can tell. So what I think is going to happen is at some point you're going to buy IoT devices. So for example, you might buy a pack of light bulbs, and then they're going to come with a light controller. And then these are all going to have built-in certs so that all these devices are uniquely identified. But those certs are going to be generated by whoever the manufacturer was. So it can be trusted to a certain degree in that you can, of course, trust that the cert is unique and all that, and it's not going to conflict amongst each other. But if the provider, if the hardware manufacturer gets compromised and their root cert is gone, then you can no longer really trust this communication method because these certs might now be invalidated. Somebody else might come in with their own certs and pose as part of your network. So I think what's going to end up happening is users are going to end up buying their own root certificate authority, basically. It might be a key fob, it might be something on their phone, it'll be some kind of secure root of trust for them that they can use to authenticate all their devices, to generate certificates for all of their devices. So what might end up happening is once you've bought this light hub with all the light bulbs, you'll use your root certificate to generate a bunch of certs for the light hub and for the light bulbs. But you might not necessarily want to replace them. So I can see a lot of these devices storing multiple identity certificates, and then you could use different certificates or combinations of certificates depending on how strong you want the authorization to be, how strong you want to manage that identity. But ultimately, you'll have your own root CA, so whatever you've signed with your certs and whatever other devices then sign other devices, so like the hub can sign the light bulbs itself, all of that is going to work based on your cert. But that's not going to change the fact that ultimately at the beginning, when you have bought these devices, you're still going to want to have physical access to be able to change the certificates. You don't want to do that online somehow because that can, of course, be compromised as well. So whether it's actual physical access and pushing a button or NFC or something like this, you're going to have a way to load your certs onto the devices and then configure them in some basic way. Probably it's going to be like a mutual web of trust as well. So we've got PKI going on here, but then there's also going to be kind of a PGP thing where each device will know the certificates of other devices to which it can communicate. So then even if the root CA somewhere for your manufacturer is compromised, you don't really care because unless they can regenerate the exact cert that you're using for one of your devices, which has been authenticated as my light bulb can trust this light hub specifically with this cert, unless they can replicate that cert exactly, which is going to be pretty unlikely, that's going to be a pretty secure way of communicating, at least within your internal network. So once we have actually defined which devices have names, which devices can communicate with which devices, and how they can authenticate each other, we're going to have quite a lot of different devices that are going to have different levels of IQ in your house. So there's going to be really simple devices like the thermometer. It's not going to care about authentication really, well, depending on where it is, of course. But if it's outside your house, maybe just for public use, anybody who walks by can just ask your thermometer what's the temperature. Maybe they're driving by in a bus or something. And you don't care. It can just answer the temperature and you don't have to worry about it. But then there's still dumb devices like light bulbs and speakers. You don't want these devices to be accessible by just anybody because then your neighbor could play like Rick Astley songs in the middle of the night through your speakers, right? And that would be a bit frustrating. So you're going to need a way to, well, the devices are going to need to know who they can communicate with, but some of them are not going to be able to do all of that authorization, authentication checking. So more intelligent devices like the fridge, the microwave. Your fridge might have some intelligence where it sees what's inside the fridge so it can track your usage habits, prepare a shopping list for you, or reorder milk automatically or whatever, suggest recipes to use based on what's in your fridge. But these devices probably still won't have enough processing to actually do like voice recognition or strong biometric authentication. You don't want to have to scan your thumbprint on every single, like your fridge, your microwave, your everything. That's going to be ridiculous, right? So some of these devices are not going to have all the features that we're going to expect, but they will want to use these features. They will want strong authentication because maybe I've preset certain preferences like in the oven or in the microwave because I have a certain way I like to microwave things. So then there's going to be smarter devices like your car, your phone, your computer. And I think that these are going to advertise internally within your network to whoever they've been authenticated or authorized to advertise to. They're going to advertise the potential to run processing tasks for stupider devices. So the light and the speaker can then offload the authentication checks and such to a smarter device, and it can just do that for the device and push the signed message, the authentication message back. all of this is going to have to work together seamlessly. So in the future, if I want to just turn on water in my favorite way, I might walk into the bathroom and go, Alexa. But actually by then, hopefully I can rename Alexa. So I might just go, oh, hi, Mark. Can I please have 30-degree water blasting out of my fridge? Or sorry, blasting out of my, yeah, that would be unfortunate. But I want 30-degree water blasting out of my shower, right? And so then the data flow for this is going to be pretty complicated because you're going to have sensors, presence sensors in the room that are going to need to know which bathroom you're in. You're going to have microphones which are going to record what you're saying, offload the voice, the recorded voice, to another system that can actually process your voice to understand what you're saying. And then that's going to have to be sent back to the tap or to the shower itself for the flow control and then the temperature sensors. So it's going to all have to work seamlessly regardless of who it's from, and also in a way that you can track which device is communicating with which device. So you can see how is the data flowing and who can actually affect that data, where can it go. So that's the next step. How do we ensure that the data is flowing the way we want it? So for non-technical users, we need a very clear way that they can configure data sharing rules and see exactly what those rules are, how it's configured, what's going on. So on the topic of sharing, as a species, we seem to have a really hard time deciding what can be shared and what not, and we tend to share far too much. So according to a study by Pew in 2017, 88% of millennials aged 18 to 29 use Facebook, 76% of them use it daily, and 47% of adults like retail loyalty cards. So we're already pretty used to sharing some personal information with stores or other things that we normally use, just because it makes things more convenient. And this is not a new development. In 2013, Pew, again, also saw that 92% of teens used their real name online in their primary profile. 84% of them posted their interests, and 82% of them posted their birth dates. So we're already sharing far too much information. And this whole concept of oversharing, this is actually what inspired my presentation today. And there's a quote from Mintel Marketing to Millennials in 2014 that says, 60% of millennials are willing to sacrifice some privacy for a more personalized experience. And I see the Internet of Things basically making that personalized experience everything around you, right? Everywhere you go, the shops, the environments you're in, they're going to be more like home. They're going to want to make life more like home for you, so everywhere you go, you feel comfortable. So the problem is people are going to share a lot of information, and they decide to share that information based on, is it worthwhile to share it? Well, what defines is something worthwhile? Usually, if you're going to be doing something, like an action going to a shop, and you're going to do it often, and by sharing a little bit of privacy, by sharing some information with the company, it's going to make that experience easier. That's already going to be worthwhile to a lot of people. Maybe you'll get a 5% discount or something like with loyalty cards. Either way, it's pretty easy to incentivize people to share some information. And especially from a retail perspective, if I'm going to a shop and I know what I want, maybe the shop has already communicated to me that they have a sale on something I've been interested in buying, and before I get there, they already know that I'm coming and what I'm looking for and roughly how much money I'm willing to spend, then they can make that sale quicker, they can service more people, they can have less staff. So it's a win for the retail because they'll make more money, and it's a win for me because I'm going to spend less time shopping because I actually hate shopping. I just go in, grab the first thing, and leave, right? So it's going to come down to data control. There's going to be a lot of different data, and you're going to need to know what can be shared and how to share it. And some data is going to be for the public, like the temperature outside your house from the temperature sensor. Anybody can drive by and pick it up. Then contact info, you might want that available to everybody outside, unless maybe you're like late at the bar or something and you don't want people recognizing you. Or maybe there's sales going on at a shop and everybody wants to share that. Then there's going to be private data, like your TV and internet usage habits, or presence sensors inside your house. This is going to be pretty sensitive because if somebody can just drive by and see that the house is empty because the sensor says there's nobody home, that's a pretty nice target for burglary. Then there's going to be location-dependent data. So if you go to McDonald's often and you have your favorite meal there, then maybe when you walk into McDonald's, you want them to automatically pick up that you always get like a Big Mac, a cheeseburger, and 20 chicken nuggets or something, right? They're going to have your order ready to go. On the other hand, what if you walk into Burger King? Do you want them to know your McDonald's order? Because maybe they can give you competing information, like what's the closest burger they've got. Then again, if you go to your doctor's office, should they be able to pick up your McDonald's eating habits? Or if you go to your insurance company, should they be able to pick up your McDonald's eating habits? So individuals will need easy control and easy visibility into what exactly they're sharing and where and who's been accessing it. So then that brings us to what we need to do, right? So all access to any of your data or to any of your devices will need to be logged. And I mean, however that access is. If somebody walks up to your front door and tries to scan their fingerprint or open the door, that should be logged. If they try to interface with your devices through whatever exposed APIs like REST or SOAP or something, that should be logged. And logged as much as you can, as in who's coming, where are they coming from, what are they trying to do, with what device, how. Secondly, you're going to need to be able to set permissions in a way that can expire easily. Right? If you have guests over and you want them to be able to walk in and out of your house without a key over the next 3 days while they stay, but then as soon as those 3 days are up and they've left, you don't want them to be able to walk in through your front door anymore. So you want to be able to set clear windows, and if they leave early, you also want to be able to just close that a day earlier or whatever, and that's got to be done easily as well. Then different places are going to have different permissions. So you might have your smart car parked in front of your house, and while it's parked in front of your house, it's fine if your wife or your kids go up to the car, open the door, roll down the windows, stream music through the speakers. But then when the car is parked at work, that shouldn't happen anymore, right? Because you don't want remotely your kids just rolling down your windows and playing music through your car, or letting people just open the doors or whatever. And then there's going to be different levels of authorization for everything that we don't even realize yet. So, for example, if you have smart windows, where can you open that window from? Can you open it from inside the house or outside the house? Or what if it's your kid? Do you want your kid opening the window all the way or only halfway so they can't fall out? So there's going to be a lot of extra choices to make, much more granular choices around authorization. And this is going to be something that we're not really used to, because it's choices that we just do as we do them, and it's not really something we think about from like a roles and authorization perspective. And these permissions might change frequently. You come home and you want to share what you're doing. You're watching a movie or you're playing games online, and that should be shared with your friends list, right? But then what if you're having a date night? You don't want your friends just coming over and saying, hey, how's it going? I'm going to join you watching this movie, but you got a date over, and that might be inconvenient. So, well, let's just finish this up then. So, all of this is going to need to be controlled in an easy way, and I see that that's going to be done. We already have some interfaces for controlling this in an enterprise fashion, and I think what's going to happen is we're going to have an Internet of Things hub built into the house, and that's going to present you an easy-to-use interface, and probably by then it'll all be done through your phone or whatever. You'll just have voice recognition. You can speak to it to give it clear rules, and it'll be able to speak back to you to clearly state what exactly is happening with all the different rules. It's still going to be pretty complicated, though. So next, once you've got device identity and data flow nailed, you've got device ownership, which is where do you belong? Who owns a device? Who can actually configure it? Who can change the settings? So you're going to move into a house, and it's going to have a lot of stuff built in the future, right? You're going to have a home IoT hub built in. You're going to have a door and window hub, which is going to control the doors and windows. You're going to have a utility hub, which then connects to your gas meter, your water meter, maybe your fire alarm as well, just your fire sensor so that it can contact emergency services. Then there's going to be additional things built into the house. You're going to have your light hub controlling multiple light bulbs. You're going to have a speaker hub controlling speakers. You're going to have microphones everywhere. You're going to have all kinds of presence sensors and things scattered around the house. But who actually is going to own these, right? Is it you? Is it the guy who made the house? Is it the person who was the previous owner of the house? Are you doing an Airbnb type thing and there's somebody staying for the weekend? Do they now own these? Everybody's going to need a clear way of seeing who owns the device, who can control the device, and where the information that the device has is going. You're going to bring your own devices as well. You're going to have your own IoT hub. You're going to bring in an appliance hub to control your TV and your fridge and your other TV. Your own light hub for your own light bulbs, and maybe you've got like an IoT disco ball in your bedroom. You'll have a speaker hub with all kinds of speakers everywhere. So again, you're going to need to be able to easily connect with the existing devices, and you're also going to want to have redundant control so that when you bring in your own light hub, it can control the lights that are built into your house. And additionally, the light hub that's built into your house, it should also control the lights that you brought because you want some redundancy there. So once these devices all know each other, once you've enrolled them, generated certificates for them, created the web of trust for all the devices so they know who they can connect with and talk to, you're going to have quite a mix of devices, quite a mess, basically. It's going to look maybe simplified a bit like this. This is a very simplified view. And to me, this kind of begins to look a bit more like an enterprise network, where you're going to have various different exits into the internet, maybe through the IoT hub and maybe through your user IoT hub. Those will both have their own ways out into the internet. You're going to have different groups of devices that are going to be segregated based on their function and what they do. But ultimately, there's going to be an issue of control of the data flow. How does the data get from all of these devices out to the internet or to wherever it needs to go, right? So especially for your utility meters, like your gas meter, your water meter, your fire alarm, the utility companies are not going to want you to have control over that. So if you're controlling the last step from your home network to the internet and you can just block the electric meter readings or something, then utility company is not going to be very happy about that, because then you might be able to tamper with the data, though hopefully we've got good encryption of the communication so you can't really tamper with it, but at least you could cut it off, and then they might not know what's really going on, and then that could impact you. So probably it's going to be enforced that certain devices, like your meters and your smoke detector, can only go through the home IoT hub out to the internet. But on the other hand, all these other devices, like your door control, your speakers, and your lights, you don't want that going out through the home IoT hub, because then you don't really have control over it. You don't know what's happening there. It might be that actually there's a hole that somebody, the previous owner, opened a thing in the home IoT hub somewhere, opened a port or whatever, and now all your speakers can still be controlled remotely, right? So you want to be able to lock that down while not disrupting the things that should not be locked. So you're going to have your own IoT hub on the side. You're going to want to route a lot of this traffic through your own IoT hub, but then you're still going to want to be able to monitor what's going out the home IoT hub. So I can see basically some interconnectivity, like a monitoring channel from your user IoT hub to the home IoT hub, so you can monitor what's going on. A way to configure all of these. We already have pretty good interfaces. For network management, there's already pretty good ways to visualize what exactly is happening on your network, how do firewall rules and such work. So I think that if we keep progressing in a user-friendly way, especially the cloud is also providing a lot of tools to manage a variety of devices, all these technologies are going to work together to make a nice interface that I think users are going to be able to use pretty easily to control their data flow. So then, what might the final destination look like? So once we've actually got device identity sorted, and once we've got data flow sorted, as in we know exactly how the data is going, where it's originating from, where it's going to, we've allowed all the data flow to happen, and we know who owns every stop, then we can see maybe what might the future look like in this case, right? So multi-factor authentication nowadays usually means you're going to get an SMS or you've got some kind of dongle flashing numbers on you. So you've got to do your password and then you've got to do an extra thing. And that's pretty cool, but it's not really, I don't think it's the way things are going to go for sure. There's also new multi-factor authentication. Even just this week, a company, I think Tokenize, they announced their token ring. And so the idea is it's a ring that's got a built-in fingerprint sensor. So when you put the ring on, it can automatically check, is the fingerprint correct? And then while you're wearing the ring, it can be automatically used to authenticate things, to unlock your phone or whatever. That's pretty cool as well, but it's still tied to this one device. It's still this one ring which you've configured and enrolled. And I think that's far too high a barrier of use for just every day by everybody, right? So what I think is going to happen is there's going to be, of course, a lot of smart devices like a smart tie. Now, maybe the smart tie is not going to be super smart. All it's going to have is just some kind of identity, of course. It's going to have a way to communicate through like a body area network or something. And then it's going to have sensors inside to tell when it's being worn and when it's taken off. So in the morning, before work, you're going to get dressed. You're going to put your tie on. You're going to put your smartwatch on. You're going to grab your briefcase, put your smart shoes on. And then you're going to authenticate on your phone. And that might have some kind of strong biometric authentication, like fingerprint or voice auth or whatever it's going to be. And once you've authenticated in a strong way, this set of devices that you're wearing, all the identities, all the certificate identities of these devices, they're going to be combined into a set of identifying certificates. And then this set of identifying certificates now becomes the digital you. It's your new digital identity. It's your identity in this world of digital devices, and this identity happens to be attached to this sack of meat that's carrying everything around, keeping it all connected. And if you take your tie off, and it can detect that it's no longer being worn, then maybe it'll invalidate the certificate that it's wearing, that it's contained. And now that tie will no longer be able to sign any kind of messages saying that, yes, I'm still part of that original group, that original entity, and I'm no longer part of that identity, right? So what might end up happening is you register the set with your home PC when you're leaving the house, and now your house already knows that this is you. And maybe when you're coming back to unlock the door, it needs only 3 out of 5 of those certificates present to unlock the front door. And that's pretty good. I mean, I think that there's a certain number of devices, of multi-factor devices that you can use on you. And if you reach that number that's safe, that's secure for everybody, I mean, some people they want to have 5 or 10 devices or whatever, and then you'll have like embedded chips and stuff, which people already do, right? But some people will be not as strict about it, and maybe just 3 or 2 is fine. Maybe just your phone is fine. I mean, nowadays we just use a piece of metal to unlock the door, right? And that can be easily copied. It can easily be hacked, basically. Like you can lockpick. There's a lockpick seminar going on as well, right? So it's pretty easy to get through a locked door. But if you have multi-factor that's securely configured by you in the first place, is that going to be enough to trust? So then that's going to bring us to who can actually unlock your front door, right? So potentially you're going to have biometrics like being able to scan your eyes, being able to use your hands, your fingerprints, or your actual key, which I don't think is going to stick around very long. But then how does your home know that you are the person authenticating, right? So you have these 5 devices, but maybe your home PC is crashed, right? So maybe that's no longer stored there. Well, maybe you want to keep a backup of that set of identifying certificates somewhere online at an identity provider. Maybe somebody like Facebook, right? Who would trust Facebook to unlock their front door? Yeah. So that's fine. I wouldn't either. But then what if Facebook and Microsoft and Amazon and Apple, Google, everybody has some sort of online identity provider service, and you can use all of them. So the moment you leave the house, or the moment you authenticate on your phone, actually, the set of identities of devices that you're wearing is going to be communicated with all of these services online. They're all going to have an understanding of which devices represent you now. And then when you try to authenticate using these devices, maybe you need a consensus, again, among all 5 of these online service providers, or maybe like 3 out of 5 of them. Maybe there's going to be hundreds of them, right? Maybe you'll have your own server somewhere that's acting as your own identity provider as well. So how many redundant online services do you need confirming that this mix of certificates that you're wearing is you before you actually consider it safe enough to unlock your front door, right? And then how does that change when you're trying to unlock the door at work? You know, you're trying to get to work, you're just authenticating. Instead of having to flash your badge, or instead of having to show your passport to reception or something, what if you can just walk into the front door and it'll automatically pull all these online places and see, is this actually the person that was registered in the morning, and can he unlock this door? Is that going to be acceptable to the work environment? That's going to be a tough question, I think, for every organization to answer, and it'll depend on, of course, how secure the company is. If it's just a shop, then it might not be a big deal. You can just walk in with your phone, and that's probably enough, or maybe 2-factor or 3 factors. That might be enough. But for something like a security company or the government or whatever, they might need quite a lot more, and they might still require you to also have a dongle or to do fingerprints or something. So I seem to have actually run through this pretty quickly, so there'll be more question and answer time. But once we have solved identity management using PKI and PGP technology, using the chain of trust, the web of trust on all their devices, and once we've solved the data control issue by having easy rules which can be configured by your Internet of Things hub, and once we've solved the device ownership issues, like having multiple certificate chains and webs of trust, chains of trust, all this, we should have a very reliable and trustworthy and effortless global individual identity management system. And this is going to facilitate us doing whatever we want to do in a way that we don't really have to think about authenticating. So imagine waking up in the morning and you get on the bus, and then you get on the train, and at no point did you have to scan a bus pass or a card or anything. It just automatically knows who you are. Maybe you don't have like an account with them registered or whatever, but you have some kind of generic thing set up where for any charges under €5 or something, it'll automatically just deduct that from your bank, because it knows that this is you, you've authenticated with all these devices, you've configured it so that you have authorization, you give authorization to make these small charges wherever you go, and then it'll just seamlessly work. You'll be able to go wherever you want to go. You'll walk into a store, it'll know who you are, it'll know where you've been. Maybe you're returning a device at a store, right? And you're not happy with it for some reason, and automatically you can then share that on Instagram or whatever, and then all your followers can see that you didn't like this device. And then a manufacturer of a competing device can offer you their product and show, hey, you didn't like it because of this, here's why ours is better, we're also going to give you a discount, right? So it's going to connect a lot of points in our lives together, and it's going to make life just easier to use and more at home everywhere. And so, yeah, for further reading, there's a few IoT platforms. There's AllJoin, there's the EdgeX Foundry, IoTivity, OpenIoT, there's Co-op, Zigbee, Z-Wave, Tokenize and Token Ring, that's what I mentioned earlier with the ring. There's also Heidi's, which is something similar. Yeah, and I'm about 10 minutes early, so if anybody has questions. Yep. Is it easier? Yeah, is it easier to actually just turn on the shower versus speaking it out? Yes, that's the question. Well, indeed, it might be, and certainly nothing's going to prevent you from doing that. And I think that, of course, there's going to be like a dial on your shower to set the specific temperature you want and the pressure that you want. But if you can have it done automatically, maybe based on your preferences, maybe you do sports every Friday, and when you come home from that, you have your own routine where immediately you throw clothes into the washing machine and then you go take a shower. If your house can automatically predict that this is what's going to happen, then everything's just going to be ready for you as soon as you get home. You'll get home, the washing machine is going to be ready with the detergent loaded already. You can just dump your clothes in and then go jump in the shower without actually having to touch anything, right? And I think it's just going to be so easy that we're going to get used to relying on all of our devices knowing what we want before we even realize we want it, that we're not going to want to use all this manual stuff. Any other questions? Yep.
What do you think will happen when everybody is used to that life after 10 years when the internet crashes?
Yeah, indeed. We are going to have to make the internet much more secure and robust and redundant. I think that there is probably quite a big chance that things are going to go wrong when everything goes down. I don't know what's going to happen. Anarchy? I think that a lot of people are going to become reliant on this. I mean, already a lot of people rely on the internet in general, especially younger kids. They just rely on the internet being available all the time and being able to access anything. And when that is not available, they're just not going to know what's going on, right? Even now with Google Maps and your GPS, when you're going around, you expect that to work. And when it doesn't, it's hard to remember how did people actually use maps before, right? Before there was a pin showing you where you are, you had to actually figure out where you are, right? That's already pretty tough, and I think it's going to get much harder with everything in life. Anything else? Yep.
Do you think there's going to be a new generation of burglars opening your front door through your entertainment system?
Yeah, I think so, but I think that I think that the secure way of having like an IoT hub that's actually going to be the gateway to everything, ideally that's going to be configured secure by design, right? So your IoT hub should not allow access to everything inside your house by default. You should actually have to specify that, yes, this kind of data can leave. You'll have to specify which way it can go, and this might be something simple like, yes, I want to share my fridge contents with my friends, or I want to share my favorite pizza with my friends, or something like this. Whatever information you have that's stored at home that you want to share with people, you're going to have to specify, but I think it'll be done in a pretty easy and seamless way, even to the point of like, if a friend asks you a question, then you can just say, okay, let him have that data, right? And then your phone will pick up that you said that, and it'll automatically pick up that you're talking to your friend, and it'll authorize him for that information. So for example, you're coming home with a bunch of buddies, and you say, hey, we're going to go home, order us all our favorite pizza. So then your computer at home, or your phone, or whatever, needs to know everybody else's favorite pizza. So did they have to pre-share that information with you so that you can place the order? Do they each pay for their own pizza? So is it like a distributed order where your computer triggers each person to make their own order and pay for it themselves? Somehow like that. I think that all of this is going to be pretty seamlessly solved. Like it's going to be, you're going to pre-configure it, or just based on verbal communication with your friends, it's all going to be set up pretty easily. And then as far as on the bigger picture, like being able to hack in remotely, like somebody outside hacking into your TV, they shouldn't be able to detect your TV at all. They should not be able to connect to it. By default, it should not be, sure, it can be using IPv4 or IPv6 or whatever, but it should not just be exposed to the internet by default. Your IoT hub should be effectively a firewall that's going to block all that access.
How much time would it take till we're in that future?
Okay. On aggressive schedule, I think 5 years we'll start seeing a lot of these changes. Or more reasonable, I think 10, and I would say 15 years tops. We'll see quite a lot of this happening already.
Yeah, I think wearables, yes, but things in a home. I'm just redecorating my bathroom, and it will be there hopefully for the next 20 years.
Yeah.
So I won't be turning on the shower with my voice. I'm sure about that.
I'll be an early adopter, I think.
Okay, thank you very much, Michael, for your
Thank you very much.
presentation.